So in the last video, we talked about server-side rendering, and in today's video, we will be talking about client-side rendering. Client-side rendering means rendering pages directly in the browser using JavaScript. All logic, data fetching, templating, and routing are handled on the client rather than the server. Client-side rendering can be difficult to get and keep fast for mobile. It can approach the performance of pure server rendering if doing minimal work. Keeping a tight JavaScript budget and delivering values as possible. Critical scripts and data can be delivered sooner using a HTTP server push or link where it is preloaded, which gets the parser working for us sooner. The primary downside of client-side rendering is that the amount of JavaScript required tends to grow as the application grows. This becomes especially difficult with the addition of new JavaScript libraries, polyfills, and third-party code, which compete for processing power and must often be processed before a page's content can be rendered. Experiences built with client-side rendering that rely on large JavaScript bundles should be considered aggressive code splitting, and be sure to lazy load JavaScript. That is, serve only what you need when you need it. For experiences with little or no interactivity, server rendering can represent a more scalable solution to these issues. For folks building a single page application, identifying core part of the user interface shared by most pages means you can apply the application shell caching technique. Combining with service workers, this can dramatically improve perceived performance on repeat visits. It is important to note that the client CPU does all the processing of the JavaScript when applications are using client-side rendering. Typically, this will not be too intense and most computers should be able to handle it. The site should load pretty fast. In some cases, like an old or a cheap computer with a slow processor, you would see that having the client handle the processing is not ideal. So what happens is client makes request for API data while your data is being dynamically created by JavaScript. It can also be getting data from databases asynchronously through an API. Usually, your site will load the dynamic HTML and then you will see it populate with information from the database. It takes longer for a client to make a request and get a response from an API than a server. Talking about the speed, overall client side rendering is fast. There are factors that can affect the speed, such as the speed in which an API will respond to you, how fast your hosting provider sends a response, your internet speed, and your CPU processing power. So basically, the client is going to request to the server is going to give the client basic HTML, then the client is going to fetch that data from the API or database, and then it is going to display the data. Now we will be talking about combining server rendering and client-side rendering via rehydration, often referred to as universal rendering or simply SSR. This approach attempts to smooth over the trade-offs between client-side rendering and server-side rendering by doing both. Navigation requests like full page loads or reloads are handled by a server that renders the application to HTML. Then the JavaScript and data used for rendering is embedded into the resulting document. When implemented carefully, this achieves a very fast speed and it has a speed compared just like to the server rendering. Then picks up rendering again on the client using a technique called rehydration. This is a novel solution, but it can have some considerable performance drawbacks. So, the primary downside of SSR with rehydration is that it can have a significant negative impact on the time, even if it improves the performance. The pages often look deceptively loaded and interactive, but cannot actually respond to input until the client side JavaScript is executed and event handlers have been attached. This can take seconds or even minutes on mobile. Perhaps you have experienced this yourself. For a period of time after it looks like the page has reloaded or it has loaded, clicking or tapping does nothing. So this becomes a little frustrating. Like, why nothing is happening or why can't I scroll? This is the problem with combining server rendering and client-side rendering. So there is still hope for SSR with rehydration, though in short term, only using SSR for highly cacheable content can reduce the delay, producing similar good results to pre-rendering. So steaming, server rendering, and progressive rehydration. Server rendering has a number of developments over the last few years. Streaming server rendering allows us to send HTML in chunks that the browser can progressively render and it's received. This can provide a fast and good markup arrives to the user faster. In React, streams being asynchronous in render to node stream method compared to synchronous render to string means back pressure is handled well. Progressive rehydration is also worth keeping an eye on and something React has been exploring. With this approach, individual pieces of a server rendered application are booted up over time rather than the current common approach of initializing the entire application at once. This can help reduce the amount of JavaScript required to make pages interactive. Since client side upgrading of low priority parts of the page can be deferred to prevent blocking the main thread. It can also help avoid one of the most SSR rehydration pitfall where a server rendered DOM tree gets destroyed and then immediately rebuilt. Most often because the initial synchronous client-side render required data that wasn't quite ready, perhaps awaiting prime resolution. Next thing which we are going to discuss is partial rehydration. Partial rehydration has proven difficult to implement. This approach is an extension of the idea of progressive rehydration where individual pieces, that is, components, views, trees, to be progressively rehydrated are analyzed and those with little interactive or no reactivity are identified. For each of these mostly static parts, the corresponding JavaScript code is then transformed into inert references and decorative functionality, reducing their client-side footprint to near zero. The partial hydration approach comes with its own issues and compromises. It poses some interesting challenges for caching and client-side navigation, means we can't assume server-rendered HTML for inert parts of the application will be available without a full page reload. Next, which we are going to talk about is trisomorphic rendering. If service workers are an option for you, trisomorphic rendering may also be of interest. It's a technique where you can use streaming server rendering for initial non-JavaScript navigations and then have your service worker take on rendering of HTML for navigation after it has been installed. So basically render of any three places. So DOM rendering, service worker pre-rendering and server side rendering. So this is the server, this is the service worker, and this is our DOM. So here the HTML is transferred from the server to the service worker, and again this HTML is transferred to the DOM. It returns back, that is, it navigates to the service worker and then it navigates to the server. So this is how the DOM, the service worker, and the server coordinate among themselves to work in trisomorphic rendering. Search engine optimization considerations. Teams often factor in the impact of search engine optimization when choosing a strategy for rendering on the web. Server rendering is often chosen for delivering a complete looking experience crawlers can interpret with ease. Crawlers may understand JavaScript, but there are often limitations worth being aware of in how they render. Client side rendering can work, but often not without additional teasing and legwork. More recently, dynamic rendering has also become an option worth considering if your architecture is heavily driven by client side JavaScript. So, when deciding on an approach to rendering, measure and understand what you want to how you want your app to react. So you will have to consider rendering strategies according to that. With either rendering approach, you will get a fully rendered HTML document at some point. So which one you choose, server side rendering or client side rendering, depends on the situation and on the user or the developer. I hope that you might have not understood everything what I talked about in this video. Obviously, you will not understand everything, but the main concept of server side rendering and client side rendering might be clear to you till now. So even if you understand a little bit, that works for us because we are doing a beginner friendly tutorial for React.js developers. So this can be a little overwhelming, but still you should not give up. So that's it for today's video. Do like our videos, subscribe to our channel. We bring to you videos on a daily basis for React.js beginners, and I'll see you in the next video.